Dear grade 8 chemistry students, Assalamu alaikum jami'an wa rahmatullahi wa barakatuh. In this video we are completing the last part of our lesson, the ionic compound. I hope that you keep attention and enjoy this fantastic lesson. At the end of this video, you will write the formula of the ionic compound using the Criss-Cross method. Firstly, don't forget to prepare your chemistry worksheet and the pen, please. Let us refresh the memory by remembering the definition of the ionic compounds, which are neutral compounds made up of cations and anions which are attracted to each other due to their opposite charges. A question: how can we represent the chemical formula of an ionic compound? This can be done by applying the Criss-Cross method. What is the Criss-Cross method? Let us start. So, steps of Criss-Cross method. Keep attention, guys. Step 1. The step 1 states that to write the symbol or the formula of the cation followed by the anion. So we start the step 1 by writing the formula of the cation, then we follow it by the formula of the anion. For example, let us speak about sodium ion, which is a cation, have a positive charge. We start writing the cation Na+, then we follow it by writing the symbol of the anion Cl- chloride ion, which has a negative charge and it is an anion. What about step 2? Come in. Step 2, make the subscript. Do you remember the subscript? Make the subscript of the cation equal to the number of charges of the anion and vice versa. Don't forget that, vice versa. How? So let us take the Na 1 plus and we have the Cl 1 minus. How can I make the subscript here of Na equals to the number of charges of the anion, which is chloride ion? So I select firstly the charges of each ion, then I make by arrow a criss-cross process. I take the one which is the charge of the cation, I put it here as a subscript for the chloride ion, and we take the charge, the number of charges of chloride anion, and put it here as a subscript for the sodium cation, as you see in the video. What about the charges positive and negative? We cancel it. They cancel each other. So this is the step 2 performed as you have seen. What about step 3, which is the last step? Write the subscripts. The formula of compound is Na1Cl1. So we have taken the one from here and put it here as a subscript for chloride, and we have taken the number of charges of chloride and put it here as a subscript for Na to get an ionic compound Na1Cl1. But the ionic compound is NaCl because we can reduce the one with this one and we get NaCl. Let us apply on an example. Here we have Zn2 plus with Cl minus. We start writing the cation firstly, then followed by the anion. Step 2, we want to make the subscript of the cation, which is Zn2 plus, equal to the number of charge of chloride ion. So here I have Zn2 plus Cl1 minus. I should take the number of charges of cation and make it a subscript for chloride. At the same time, I should take the 1, which is the number of charge of chloride, and make it a subscript for Zn. Very easy process. You see it? So, don't forget that the charges will be cancelled. What about step 3? I write the subscript and get the formula of the compound. So after making this criss-cross, the ionic compound becomes Zn1Cl2. But you know that when the subscript is 1, there is no need to write it or to keep it, so we neglect it. We have now ZnCl2. This is the ionic compound. This 2 is the subscript of Cl, while 1 is the subscript of Zn. So I have here 1 Zn2 plus and 2 chloride ion. When we have this ionic compound ZnCl2, this means that this ionic compound is made up of 1 cation Zn2 plus and 2 chloride ions. So write the formula of the compound containing the pair of Mg2 plus, which is magnesium ion, and OH minus. Step 1, we start by writing the cation Mg2 plus, followed by the anion OH minus. Step 2, we make the criss-cross between the charges and the subscript. As you see, the 2, which is the number of charge of the cation, becomes the subscript of the anion, while the number of charge of anion becomes the subscript of the Mg cation. Step 3, we write the subscripts to get the ionic compound. So we have Mg1OH2. So as you see, in the ionic compound, we need 2 OH minus, 2 anions of OH minus, to balance the 2 plus of the magnesium ion. So each magnesium ion has 2 plus, need 2 ions of OH minus to get balanced. So we should put the brackets, because if the bracket is not placed here, we will get the following MgOH2. This 2 will be for the hydrogen. As you see, 1 Mg, 1 O, and 2 H. And this is wrong. It is false. We need 2 OH, not just 2 H. So, to express this in correct way, we should put the brackets here, before and after OH. And the 2 here becomes for representing 2 oxygen and 2 hydrogen, not 2 hydrogen only. Keep attention for this important note, guys. An application. Write the formula of the compound containing the pair of NH4 plus and S2 minus. We start by the cation, step 1, followed by the anion S2 minus. Step 2, we make the change between the number of charges of the cation becomes the subscript of anion, and the number of charge of anion becomes the subscript of the cation. Here we have 2 and 4. We will see what we will do. Step 3. So I have NH4 2 S1. So we need 2 NH4 in order to balance the 2 minus of the anion of the sulfide ion. So when I need 2 NH4, the NH4 should be kept between a bracket, not left without brackets. So the ionic compound becomes NH4 between brackets 2S. Other application. Write the formula of the compound containing the pair of Al3 plus, which is aluminum ion, with the SO4 2 minus. We start by the cation, and here I put the SO4 between brackets because the charge is for all the polyatomic ion. Step 2, we make the criss-cross. The 3 charge of the aluminum become a subscript for the SO4, while the 2 of SO4 becomes a subscript for aluminum. Step 3, we put the subscript Al2SO4 between brackets 3. An application: write the formulae of the ionic compounds made up of the following couple of ions. So here we have the two ions, Ca2 plus with CO3 2 minus. We start by the cation, followed by the anion. The second step, we make the criss-cross between the charges. But here, if we observe carefully, I see that the number of charge of the cation is 2 and the number of charge of the anion is 2, so they are equal. Here there is no need to make the criss-cross because we can cancel the 2 plus with the 2 minus. So the 2 plus charge of Ca ion can balance the 2 minus charge of sulfide ion. So no need for a criss-cross. The ionic compound becomes CaCO3. Other example, we have the iron ion Fe3 plus with the PO4 3 minus. Here also, if you notice, the charge of the cation is 3 plus balance the number of charge of the PO4 3 minus, which is a phosphate ion. So there is no need for a criss-cross. The ionic compound become FePO4. So keep in mind always that when the number of charge of the cation equals the number of charge of the anions, the two opposite charge balance each other, so no need for the criss-cross. Note: when writing the formula of the ionic compound, some notes should be acquired and known before. Keep in mind, guys, first note, the cation must be written before the anion. Second note, the charge of the cation becomes the subscript of the anion and vice versa. Third note, polyatomic ions must be put into brackets if its subscript is more than 1. And finally, use the least common multiple, LCM, to reduce the subscripts. For example, the correct formula of the compound obtained from Ba2 plus and S2 minus is BAS, not Ba2S2. So when I should keep attention and I should notice that when I want to write the subscript, I should take the least common multiple. Finally, for the next time, solve and memorize numbers 2 and 3, page 22, worksheet 9. And solve the application about the criss-cross in worksheet 9, page 22. I hope that you have understood the concept and you have get an enjoyable time with this lesson. تقبل الله أعمالكم. Study well. السلام عليكم جميعا ورحمة الله وبركاته.